Concept question number 11 on page 807 of chapter 24. Two long wires carry currents in directions shown in figure 1. One wire is 10 centimeters above the other, like in front. In which direction is the magnetic field at the point halfway in between them? So, halfway between this wire and this wire, what's going on? So I got the front wire and the back wire, and we're looking what's halfway in between. Does that make sense?
Yes.
So what's the, forget there's two wires, pick one wire. This one?
Yeah.
What's the direction of the magnetic field doing at that point we talked about?
Going into the center. Going to the right.
It's wrapping around this way. And what is the direction behind the wire?
To the right.
It would be to the right. Okay. So right here, let's call this 1 and 2. Does that make sense? This point in space is actually behind this front wire. So I grab the front wire, I'm looking what's behind it. The fingers point to your right. Okay. Second wire, what's in front of the second wire? It points down. So this wire has a field that goes like this. Okay? So in front of this wire, the magnetic field points down. How do two vectors add? They're the same size currents and everything. So the net field would be at 45 degrees between those. Does that make sense?
Oh.
So you say, what is the direction of the field halfway between this wire, and this wire? Look at this point in between. It's kind of difficult to visualize.
I guess it's the wrong question.
It's an odd question, but that was worthwhile. Okay, let's do a direction of field from a coil.
Yeah. Pick one. That's what's happening underneath. Object. Going that way.
I missed that. These are hard to draw. Okay, so I'm not sure. Can you tell what this is?
Yeah.
Okay, there's an axle, and what way is it coiled? It's coiled like this. So this wire is in front, coming down, and this wire is in the back, going up. Does that make sense?
Draw arrows.
Okay, well, I'll draw a current. How about that? This is in, first I'll say this is in back, and this is front. If the current is up, what's the direction of the field in the coil?
If what?
What right-hand rule are we going to use?
Death grip.
Death grip. We're going to grab a wire. Where do I grab? The top? Lacey wants to grab the top.
Where are we looking at it? Just like this way?
I don't care where you're looking at it from. You're sitting there, so either way we should be able to draw the orientation.
So you're just saying left or right?
Yeah.
Okay.
Yeah, left or right. So in this situation, what's the current, the direction of current as it goes into the board? Current comes up and goes like that. So these are all X's for the current, not the magnetic field.
Wait, so that's in front?
This is in front, so the current comes up and goes behind.
What? The current's going on.
So it's this to the left.
Right.
So if we grab currents in like that, magnetic field is to the left.
Oh, yeah.
So let's do it this way. Let me grab the wire here. Behind the wire, which is going to be the center of the coil, the current's to my left. This points left. As I go around, as this comes up, like this, I'm going around like that. But I'm always pointing, these always point towards me. The magnetic field always points towards me. Does that make sense?
Can you go like this, or do you go like up? Because it's always going to point, your thumb is always going to point up. There's something you go like.
You can do that, that's no rule we teach in class. Though. I only teach the rules we teach in class. So, in this situation, we're using the death grip to find the magnetic field inside the coil. My fingers are behind the front wire, current is up, therefore it goes to the left. Does that make sense? If you see a picture and it's unclear how the coil is turned, feel free to ask. I'll definitely answer. These can get kind of complicated, right? Other questions? Yeah. That's not a question, that's just sitting there going. Are we toast or room for a little more here? More. Bring it on. It sounds like magnetics are the hardest thing, is that correct?
Mm, so.
Okay.